Saxon Algebra 1, Lesson 69. Students, it's a red letter day in your algebra education. We're going to start learning something that you will look back on many times in your future algebra career and think, oh, that seems so weird. I didn't know how to do that. Now it just seems like breathing to me. So the topic is called factoring trinomials. But before we get into that, let me back up and remind you of something you already know. You know what to do when you see a problem like this. This is what we call a pair of binomials, and we multiply them together, right? You know that you're supposed to multiply these two things. And you do it like this, right? We write one of them above the other, and then we do that dance thing, right? You imagine the little 10-year-old kids learning how to dance in the dusty studio with the sun shining in and the dust in the air and the wooden floor. And the teacher makes them all dance with each other, right? So the boys are here and the girls are here. This girl starts. She dances with the first boy, and that means we multiply them. X times x is x squared. And then she dances with the second boy. We multiply them. Positive 5x. All right, now she's done. She's taken her turn. And now this girl stands up. She dances with the first boy. And look, we notice that their product kind of goes with this one, doesn't it? It's not an x squared, it's a plain x. Oh, okay. And then when she multiplies with this boy, we notice, oh, that's actually a third thing. So we write it like that. And then we add it up, and what I'm going to do is I'm just going to write the answer down here. It's x squared plus 3x minus 10, right? That's the answer. I just wrote it over there. So what we just did is called, or should I write it? I'll write it here. What we did here, this is called multiplying binomials. They're called binomials because they each have two parts, right, within the parentheses. That's what this is called. These are called binomials. Right? This is called a trinomial. You're copying all this down, right? This is called a trinomial. 3 pieces, get it? Clever, right? Now, when we want to go and turn this back into that form, it's called factoring trinomials. Look, that's the name of the lesson. So what we know how to take these and turn them into that. Now we're going to take this and figure out how to turn it back into that and like complete the cycle, right? Okay, so what we're going to do is we're going to start with this trinomial. It's actually example 69.2. We're going to go back and do 69.1. I like these numbers better. And I'm going to show you how to do this. At first, it's going to seem confusing and weird, but you'll get the hang of it and it'll be easy. Okay, we start with this, and we know that to turn it back into binomials, we're going to want two things that look like that, right? We're going to want the parentheses, and we know we're going to want an x at the beginning of each one. That's easy. And for a long time, we'll have the plain x squared here, no number in front of it. That means we know we can set it up just like this. Now, we need to put a plus or a minus sign in each of these spots, and then we need to put a number at the end of each of these, right? Just like this. So, how do we figure out how to do that? Here's what we do. We write down pairs of numbers The first thing we do is we write down pairs of numbers that multiply to the last term. In this case, it's minus 10. Okay, it's the one that's by itself, no x with it. All right, so let's write down all the pairs we can think of. Well, there would be 1 and minus 10, and there would be -1 and +10, right? Those are pairs of numbers that would multiply 2 minus 10. But we could also do 2 and -5 and -2 and +5, right? And we want to write down all the combinations with the plus and the minus, just like that. Now, once we've got all those written down, we want to now, among these, we want to look for the pair of numbers that add to the middle term. In this case, it's +3. All right, so we can see right away, well, this difference is going to be a -11, and this difference is, or it's going to be 11, and this difference is going to be 10, right? Neither of those are going to work. But look at this. If we add 2 and -5, what do we get? -3. Oh, we want +3, so we want this pair. I swear I didn't write this on purpose to build up the suspense. -2 and +5, when we add them together, we get +3, and that's what we want. Now, at this point, it's what I call an art project, because we don't have to do any math. We just have to write it so it's pretty. So what we do is we take this pair that we chose as our winners because they multiply to the number in the last term and they add to the number in the middle term, and we just write them in here, -2 and +5. And that is our answer. And when we go back here, we go, oh yeah, there it is, +5 and -2. Now, I wrote these in the opposite order than I did up here. That's okay. It doesn't matter what order we write those in. It does matter that we get the proper sign with the right number, right? Because it does make a difference. In this case, we need it to add to +3, and if we mess up the signs, we're going to get -3. So you have to be careful with the signs, but the order of the binomials, that doesn't matter. Okay, so there's one example. So let me just remind you, these are the super important rules that you want to hang on to. We write down the pairs of numbers that multiply to the last term, and you choose the pair that add to the middle term. As we get better, we won't have to write this down like this. We'll be able to just manage all that in your head. But for now, writing it down is going to help you a lot. Okay, let's do another one. Let's go back and do 69.1. Ready? So here it is. Now notice there's a right and a wrong way to order this, right? We always want the x squared term first, then we want the plain x term, then we want the plain number term. We'll talk more about that later, but for now, just make sure you always have that order. Okay, so now I can do this. I know it's going to look like that. I know I can put the x's in. Now I'm looking for pairs of numbers that multiply to 15, and let's do 1. Oh, they have to be -15. The sign matters very much. 1 and -15, -1 and +15, and then 3 and -5, 5 and -3. I'm erratic in the way I skipped that. All right, the number that we want them to add to is -14, so we can see, oh look, I didn't even have to keep writing, did I? That's the one we want. And so we write x plus 1, because the 1 is positive, and -15. There's the art project part, right? And I'm sorry, I'm just looking at the way John's written this answer. -15 and +1, that's correct. Okay. Yay, the other one was right too. I don't know if I marked it right. All right, and I think there's one, oh, there's a couple more. 2 more. 69.3. Well, 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 look what old John has done. He's tried to trick us. He's tried to trap us. We're too smart for him. This bothers me very much. I see a -5 and I go, whoa, 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 whoa. I don't want to see this first. I want to see this first. And that's going to make a difference because when I'm doing this whole multiply to the last and add to the middle, if I don't have them in the right order, the whole problem is going to be a disaster. So the first thing I have to do is just rearrange. Being careful to put the minus signs in the right place. Now I'm ready to multiply. Now this is the first time we've had a positive number in the last place. So let's be careful about the factors that we can get. There'd be 6 and 1, but there'd also be -6 and -1. There would be 2 and 3, but there would also be -2 and -3. Okay, that's all I can think of. Now they have to add to -5. Okay, so right here, right, -2 plus -3. Give us -5. The Algebra 1/2 kids learned about the ladder in the meadow today, and they're practicing adding signed numbers. So feel smart. You did that a long time ago. Jackson's like, ladder in the meadow. I'm sorry, Jackson. I can't explain it to you. Watch the video for Algebra 1/2 lesson 69, and that will tell you about the ladder in the meadow, if you want to know. It'll make you feel really smart to watch the other kids' videos. Okay, so now it's just an art project, right? We set this up, and we go x minus 2, x minus 3. This is the hard part, is just thinking about the different options and getting your brain organized. And like I said, later we'll learn how to do that in our heads. But for now, I want you to practice writing it down, because the other advice I'm going to give you is that sometimes when you've been doing these for a while, you'll just get one that you're stuck on. You just can't figure it out. And if you can go, okay, well, I'm going to list my pairs and see if I can figure it out. There's one problem that I often put on the test that just stumps people. And I remind people, just write the pairs out like you did in the beginning when you were just learning this, and it will help you see the answer. So I want to make sure you get really strong on this. Okay, and then the last one, x squared plus 5 plus 6x. Once again, John is playing pranks on us. What I would say to you is that if you see he has messed it up as he gave it to you in the book, feel free to just copy it the way you know it should be. Right? There's no need to even write that down. You can fix it as you're copying. I just wanted you to see it. Okay, pairs that multiply to 5, positive 5. Well, that's going to be pretty easy because there's only 2, right? And we want it to add to positive 6, so there it is. And our answer will be x plus 5 times the quantity x plus 1. And that is correct. Okay. Yay. And I want to remind you what we're doing here. We've learned how to take binomials. We already knew how to multiply them and make a trinomial. Now we know how to take the trinomial and break it back down into binomials. And that word is called, that process is called factoring, breaking it down into smaller parts. All right, lesson 69 has come to a conclusion. Yay, goodbye.